is a chemical reaction? What are the signs of a chemical reaction? What are the types of a chemical reaction? These are questions we're going to be answering in today's lab. This is the Chemical Reactions Lab. Would you believe that right this very second, there are millions of chemical reactions happening around you? I mean, think of it this way. Plants will take sunlight, carbon dioxide, and water and turn them into glucose. A series of chemical reactions makes that happen. What about that snack you had just a little while ago, or maybe the breakfast that you had this morning? The digestive process inside you is all a bunch of chemical reactions happening. How about those fun little glow lights that you carry around at Halloween? That light is produced by a chemical reaction. Or think about the batteries that power your flashlights and your radios and your watches. The result of that current is a result of chemical reactions. And even something as simple as a candle burning is a representation of a chemical reaction. In order for a chemical reaction to happen, certain bonds have to be broken and they have to be rearranged, because one of the rules of a chemical reaction, in fact, the biggest rule, is that what shows up as a product of a chemical reaction is chemically and atomically different from what it started out with. In today's lab, we are going to be examining exactly that. We're going to be going through a large series of chemical reactions. You are going to be recording the qualitative data from each of these reactions. And then we're going to move into a second part in which we will actually collect some quantitative data of a chemical reaction. It's a lot to handle, but it's going to be a lot of fun. Are you ready? Let's get started. To set up this experiment, we have prepared a series of 1 molar solutions, and I will tell you exactly what we have. Now, I will remind you that your lab protocol asks that each of these solutions be dispensed using a dropper bottle. We didn't have that available at the time, so what I've done is I've actually placed those solutions in test tubes, in plastic test tubes, and I'm using a plastic dropper to dispense them, okay? So let me tell you what we have. We have 1 molar calcium chloride, 1 molar sodium phosphate, 1 molar hydrochloric acid, 1 molar sodium carbonate, 1 molar copper 2 sulfate, you see that blue color, and finally 1 molar sodium hydroxide. Of the solids we have today, we have ammonium chloride and strontium hydroxide. That's going to be one of our test labs today. And for one of the specifically required labs that we have today, we were supposed to use copper 2 carbonate, but we don't have a sample of copper 2 carbonate available right now. So I'm going to be using sodium bicarbonate, which is also called sodium hydrogen carbonate. So, in addition to all that, we'll be running our experiments in test tubes where applicable. And we have 7 test tubes set up, 6 here and 1 over there. We have samples of metals. We have zinc as well as magnesium. We're going to need these wood splints because, yes, there's a little fire involved here. We have test tube holders as well as a pair of tweezers just to handle our material safely. We have a sample of phenolphthalein. This is a 0.5% solution of phenolphthalein with its own dropper. And as far as sensors are concerned, we're going to be doing a quantitative measurement in the second portion of this series. And we have here a wireless pH sensor, a wireless conductivity sensor, and a wireless temperature sensor. Now, let me show you about our other setup here. We have an iron stand with a clamp that is going to be holding one of the experiments we're running today. And instead of a Bunsen burner, and this is really especially important for those of you who don't have gas lines in your facility or are working from home, guess what? A camp stove, $7.50 on eBay, is like the perfect alternative to that Bunsen burner. We always have wash bottles and buckets of water available to wash any of our instrumentation. And that's essentially what you need to get this lab set up. For the qualitative section of this lab, we are going to be using our senses, and I will be telling you a few things if I observe anything interesting happening from my end. And you will be writing down all of the qualitative observations that you're making for each of the experiments that we're running today. So we will go through these experiments as they show, as they appear in your worksheet from A to H, all right? So let's start with experiment A. Experiment A says we need to mix 1 milliliter of our calcium chloride solution with 1 milliliter of sodium phosphate. Recall that each of these are clear solutions. So let us take 1 milliliter of calcium chloride, and we're going to mix that with 1 milliliter of a solution of sodium phosphate. What are you noticing? There's something interesting happening here. You notice that we started with 2 solutions. When you mix the 2 of them, all of a sudden what you see is essentially a white solid being formed. That's an important observation to make. You mix calcium chloride and sodium phosphate, and you get a white solid precipitate formed. That is experiment A. For experiment B, we are going to be heating up our sample of sodium bicarbonate. Now remember, we could have used copper 2 carbonate, which is what is it written in your lab, but we didn't have any. So today we're going to be running this experiment using sodium hydrogen carbonate. So as we are heating this up, I'm going to take a lighted splint. One of the first things I notice is that there's a little sweating going on in there. That means water is being produced by heating up sodium bicarbonate. And then we take this lighted splint, and it seems to keep on dying on us. That is an important telltale sign, because that means that there's a gas that is being produced in there that is very good at putting out a lighted splint. So that's for you to note as another qualitative observation. Experiment C says we're going to take a piece of zinc. So I have done exactly that. And we're going to put it in a test tube with a relatively loose cap. And we're going to add a little bit of hydrochloric acid to that. In fact, we're going to add 2 milliliters of hydrochloric acid. There's 1. And there's 2. Let's see if anything exciting is happening here. Let me keep my little flame going here. So one of the first things I'm observing from my end is that there are bubbles forming on the piece of zinc that we have. That's an important observation to make, right? Whenever bubbles are forming, that means a gas of some kind is being produced. interest of time, I am simply going to set that aside. We're going to come right back to that one when we're done, okay? So our next experiment says we're going to be mixing hydrochloric acid and sodium carbonate. So here's your hydrochloric acid. Here's your sodium carbonate. Oh, look at that. We've got bubbles forming. And once again, do you see how our splint keeps dying in there? Once again, a gas is the product of the reaction of hydrochloric acid and sodium carbonate. And that gas is very good at killing a lighted splint. Let's see how our zinc and HCl are doing. Look at that. More bubbles have formed. So we know that gas is still being produced by the reaction of hydrochloric acid and zinc. So our next reaction says we're going to take two solids, strontium hydroxide and ammonium chloride, and we're going to mix them together in a test tube, and we're going to see if there's anything interesting that happens when those two are mixed. This is strontium hydroxide, and this is ammonium chloride. Get a little bit more in there. I'm actually going to mix them together really well. So these are two solids we're mixing with each other. And I will tell you, the test tube has gotten cold. Remember how you sniff something in a chemistry lab? You waft it towards you? There's an aroma of ammonia. So it's getting cold and it smells a little bit like ammonia. So that's an important observation to make. Our next experiment says we're going to take some zinc. Yes, we're back to the zinc. And then we're going to add some copper 2 sulfate to this. And you know, I would like for this to be done on a white sheet of paper so that you can better see what is happening. So here's my white sheet of paper. Here's my piece of zinc. And now I am going to take 1 milliliter of copper 2 sulfate. I'm going to add it right to it, right there. There is a slight discoloration of the zinc when you add the copper 2 sulfate to it. Let's see if we put a bigger piece of zinc in there. Oh, there you go. Does everybody see what's going on over here? The piece of zinc that is in the copper 2 sulfate has turned very, very brown. Okay, that's an important observation. There's absolutely a chemical reaction going on in there. And then we're going to be doing a very simple experiment using phenolphthalein. I'm going to add 1 drop of phenolphthalein into this little tube over here. I'm going to be adding 1 milliliter of our base. Does everybody see that beautiful fuchsia color? I'm going to be adding 1 milliliter of acid, hydrochloric acid. Anybody notice any color changes there? Look at that. That is also a sign of a chemical reaction. Now, we are going to actually use our burner to do experiment H. Experiment H says, let's take a piece of magnesium metal and let's heat it up and see what happens. I will warn you, there's going to be a light produced, and this is the time that you want to make sure you are not looking directly at the light. So let's turn this up again. Stand away. Woo! Do you see that? I don't want to look straight at it, but that is a chemical reaction. So now it's time to actually look at what a chemical reaction looks like on a quantitative level. It is easy enough to say a chemical reaction is happening when we can see the product that is being produced. However, not all chemical reactions are visible to the naked eye. And so for that, we are actually going to be using, for this section of the lab, a group of sensors. We're going to be using the wireless pH sensor, the wireless conductivity sensor, and a wireless temperature sensor. Your teacher may give you any one of a variety of different options of the labs we tested to run. However, for this particular lab, I am going to be picking lab G, in which we took an acid and mixed it with a base. Now, if you recall, in the original lab, the color pink or magenta came out, and that was our signal that a chemical reaction happened. We're going to take that same experiment and we're going to see what actually happens in terms of the quantitative results. So for that, we're going to be using these sensors. So first, let us take measurements, and you will find this in one of your config files where you can actually find a setup that's already ready to measure your temperature, your conductivity, and your pH. I have already synced my wireless probes with SparkView, and we're going to just make the measurements for our first reactant, and that is hydrochloric acid. I should point out that I diluted both acid and base to 1/10 the strength we were using in the original lab. And that's because the limit of detectivity of the sensors is much lower. So we had to make dilutions of them. So these are 0.1 molar solutions. So for our acid, let's get our numbers down here. And I just for regularity's sake, I'm going to wait about 10 seconds before I do my final readings. I'm going to stop it right here and write all of my values. We have 23.8 degrees centigrade. We have a reading of 21,845 microsiemens per centimeter. That is actually above the limit of detection of the conductivity meter. Basically, it's very high, and we have a pH of 1.41. Okay. As always, I am rinsing my probes in a very large bucket of water. And now I'm going to be looking at our other reactant, which is sodium hydroxide. Let's let everything dry just a little bit. And let's see what that sodium hydroxide looks like. So our sodium hydroxide has a temperature of 23.7. Stop right there. We have conductivity of 15,873, and we have a pH of 12.42. So now let's give our probes another good dunking, because now we're going to mix these two reactants together. And we're going to do that in a slightly larger container. This is our 100 milliliter volume beaker. I just put in my base first. Since I'm working as a singular person today, it's much easier when you're working with a lab partner. I'm going to put in my probes, starting with the base. Watch what's happening with those numbers, okay? Oh my goodness. 6, 7, 8, 9, and 10. Let's see what happened when we mix those two. Our temperature has gone up to 24.5 degrees centigrade. Our conductivity is way down to 4,414. And our pH went from very basic to 3.31. Now you have some numbers that tell you what a chemical reaction looks like when you start making these quantitative measurements. You remember that experiment C where we mixed zinc and hydrochloric acid and it was going a little slowly? Well, let's take a look at it now. After a little while, you can see that it is almost white in color, and that's because it's producing thousands of little gas bubbles, right? But I will tell you, it's not quite going fast enough for me. So, to that, I will make one small change. The gas that's produced in this next reaction, and I'm just going to be changing the metal from zinc to magnesium. The gas that's produced in this reaction will be exactly the same gas that is being produced as we speak with zinc and hydrochloric acid. So in this tube, I have 2 milliliters of 1 molar hydrochloric acid. And just to be ready for this, I am going to light up the split. I'm going to pick up a piece of magnesium metal and put it in here. Do you see how wild that reaction is? Did you hear that? That is a very special gas that's being produced. That's what I wanted you to see with the zinc. Wasn't happening fast enough, but it's certainly happening fast enough with the magnesium. Remember that gas that's produced is exactly the same gas as what's being produced right now with the zinc and the hydrochloric acid. Now let's get to the analysis part. So now that you have all of your data, you are actually ready to do the analysis for this particular lab. This means that for every one of the reactions that you ran in the first section where you're looking at qualitative changes, you will be expected to write out the entire chemical reaction, reactants and products, and to balance those reactions as well. In addition, you will be asked by your instructor to identify the kinds of chemical reactions you are seeing. Is something a synthesis? Is something a decomposition? Is something a single replacement reaction, or is something a double replacement reaction?